Hello, welcome to Beginners Python and Machine Learning. My name is Tim Cummings. We're a meetup group, so we will try to help each other in learning how to use Python and doing machine learning stuff. I generally do the Python presentations here. We're open to volunteers who would like to present something, especially machine learning. Most of our crew are not in Brisbane at the moment. I'm the only one left in Brisbane, so it's making it hard to do in-person presentations. But if we've got any volunteers on with machine learning topics, get in contact with me, and we can have another in-person session. But in the meantime, let's go on with the online ones. So we're doing this live, so you can ask questions as we go along. You can ask them in the YouTube chat, so I'll be watching that, and also in Slack. If you're not joined up to our Slack, then the instructions are down below this video or on the meetup event on how to get invited to our Slack group, and just look in the Learning to Code channel for Beginners Python. All right. So today we're going to look at Python's built-in functions, and we're going to do that using Google Colab. So there's a link just below the video or in the meetup group to colab.research.google.com and a special notebook that I've set up for this session. So if you click on that link and open it up into a new tab or new window, you want it in a new window if you're watching this video, so that you can follow along. And there'll be exercises along the way, so try to do the exercises as well. So this will take it'll give you a link to my notebook. Changes won't be saved because you can't edit my notebook, but what you can do is copy it to your own drive. So you see here, copy to drive. So I suggest that's the first thing to do, and then you can always go back to this as the original, but you've got a copy that you can make changes to, and that's how you learn, is by doing things. So make changes, try to break things. We just don't need to read the release notes here. It looks like it's just been a release on the 12th of May. We can connect. I'll just click that now. I'll save a bit of time later. Otherwise it'll connect automatically when you start trying to do things. Now this is a notebook. I'll just hide this warning. A Jupyter notebook. So it's made up of cells, and they're code cells and text cells. So this is a text cell. It's got some formatted text in it explaining what we're doing tonight. So we're looking at how to use interactive Python, and we're going to look at the built-in functions that come with Python. We'll write a few little scripts, doing some conditionals and loops. So you can, there's a link here to this particular notebook, to the YouTube video, so you can watch it again later if you want, to the meetup event, and also to our GitHub site, where you can look at all the list of other videos that we've done online, and they'll have the links to their notebooks and YouTube videos, and maybe GitHub sites as well. All right. So this session is going to show you how to use the built-in functions which come with Python. Most functions that you use in Python, you have to import a library, either a standard library or a third-party library, to use the function. But there are some functions that the builders of Python decided were so important that they'd make them built-in, so that you can access them without having to import them at all. So they're the ones we're going to go through today. We'll just look at the ones that you're most likely to come across. This is more text here. It just tells you how to use Google Colab. If you've got any questions, just ask me, but otherwise I'll just move straight on. So first of all, I've written a little bit of code here in this code cell that's going to find the list of built-in functions. So don't try to understand everything that's going on in this cell. But there is a library called built-ins that will let you get the list of built-in functions that exist, and it's also One of the problems with a built-in function is that you can accidentally clobber it by naming one of your variables the same name as the built-in function. And if you do that, then you can use this library to get it back, so to speak. Alright, so we're going to have a look in this library and find all the functions that are built in, all the classes that are built in, and even look at these private values that are built in. Then we're just going to print them all out in 7 columns, and each column is going to be as wide as the widest. So we're going to the maximum length of any of the names that are in that list. And so let's run the cell. So you can see there's a play button here, and you can do this on your Colab notebook as well. So just press play, and the output is shown below the cell here. And you can see we've got classes, so these are all the classes that are built in. And most of these are error classes, so they're just when exceptions get thrown, they're the ones that you can catch. There's also a couple like false, and so one of the problems that we've got here is that since I wrote this code, they've introduced a private that's a lot wider than they used to be. So the 7 columns that we've chosen is not actually working. So let's change it from 7 columns to 4 columns, so we don't have to scroll. Alright, so we're not going to really pay much attention to the classes or these private values. And here are all the functions that we're going to be looking at, and just really do some examples with a few of them. Okay, so the most important one of all of these, of course, is help, because that's how we can get help on any of the other functions. In fact, we can even get help on itself. Now we're running what's called interactive Python, IPython, in this Jupyter Notebook. So there's a few different sorts of Python around, which can be quite confusing. But this one is IPython for interactive Python, and it's really CPython, which is the normal one you'd write your scripts in, plus a couple of things to make it more interactive on top of that. So let's run this cell, running help, and it tells us that we have to type help with the parentheses for interactive help, or help on an object for help about that object. Alright, so let's try the interactive help, and I've just commented that out to start with because it will interrupt your script if you try to run all the cells at once, and I don't like it when it fails at one point. But we'll uncomment it by getting rid of the hash space in front. The hash says it's a comment. So now it will run when we run it, and it'll tell us this is the help utility, and to quit this help utility and return to the interpreter, type Q. So let's try that. Okay. Now let's try to call help on another function. So if I go back to my list of functions, I'll see I've got a function here called all, and I want to see what that does. So try to think what you think all might do at this stage, and then let's run the help and see what it is. So all will turn a true if the Boolean value of every item in this list is true. Okay, so let's have a look at some examples. So we're providing an iterable, which in this case is a list, and we've got true, true, false, and true, and we're calling all on that list to see if they're all true. So obviously the answer is false because there's one false in there. Now if they were all true, it should return the value true. Now these values in the list, they can be, they don't have to be just true or false, they can be an expression that evaluates to true or false. So for here I've got true, true, 3 equals 3, 5 is greater than 1. So they're all, these last two are expressions. 3 equals 3, that's true. 5 is greater than 1, that's true. So all of those should also be true. Okay. So we're going to create a list of conditions. We want the length of the word all to be 3. That's true. We want C to be greater than A. That's true. Just true itself is true, and 5 is greater than 5. That's not true. So let's run that, and we see that our list of conditions is results in true, 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 false, which is what we predicted. And if we run all on that, then it's false because there's at least one of them is false. Now I've said here IPython stores the results of the last expression evaluated in a special variable called underscore. So you can use underscore as a variable name, but I wouldn't do it in IPython because IPython will overwrite things as you go through. So for example, if I wanted to put in a new code cell, I'll insert one there, and I'll say what's the value of the variable underscore, and that'll print it out, and the answer is false, and that's because it's evaluated the last expression of the previous cell, which was all of that, and put that into false. Now if I print it again, it might come up as none because we didn't have the print function doesn't return any value. No, okay, false. Okay, so let's try 3 plus 3. So it was false, and then we got a result 6. If I print again, well, now we get 6 and 6. So challenge here, and I've left a spare spot for you to do the challenge yourself. Get help on the any function and come up with an example where it would be used. Okay, so you can pause the video and try to do it yourself, or just follow along with me. So I want help on the any function, and you see I type in any without any quotes around it because that's actually the function I'm wanting to refer to, not the string. And it says return true if the boolean of all the values in our iterable thing, which could be a list or a tuple, is true for any x in the iterable. So last time they had to be all true to return true. Now it just has to be any one of them. Okay, and if the iterable is empty, return false. Okay, so what's some examples? Now I've got the solution here. Oh, here we go. You can use the string name of the function just after I said don't do that. So that will work as well. So that's useful for keywords. So an example here is if any of them is considered to be, so if we've got a shipment and any of the items in the shipment is considered to be dangerous goods, then the whole shipment is considered dangerous. So that's an example where you would use it. You'd go check all your items, see if any of them's true, and in that case then we'd say yes, it's true, it's dangerous. So try to think of some other examples as well where you would use that. You can see help works when you use the string value of any, and when we calculate any for false, true, false, false, we get the value true. It's just one of them, at least one of them was true. Okay, so here's a more advanced example. You have a word and you want to check if any of a group of letters are in the word. So our word is going to be beginner's Python, and we want to see if there's any of the letters A, B, C or D are in that word or phrase. So how do you think you would do that? Now I'm going to do it with a little bit more code so you can understand what's going on. So what I might do is I might go for L being letter, for letter I'll call it a letter in ABCD. Print, we can print it, yeah, letter in Word. Alright, so that'll be something that's true or false, and I'll just put the word up the front so that we've got it. Now we might want to say we'll have a variable, so we'll call it in Word equals letter in Word. If in Word, then we can print any is true. And we'll break out of the loop. And then if we didn't do that, that's when we would say we can actually put an else on the on our for loop and print any is false. So that's basically what it's going to do. Let's run it. Any is true, so it went false, true, and then any is true because the B is in there, and so we didn't get any is false. Now if we weren't checking B, if we just were looking for the letters A, C and D, we go false, 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 any is false. So it's checked all the three letters, none of them are in the word that we want, so it's printed any is false. So you can understand what it's doing, but that's a lot of code. So let's have a look at the simpler thing. We're going to use list comprehension here to make our iterable. So we put our for loop for L in ABCD, check if L is in Word, that'll return true or false, and then it'll assemble all the trues and falses into a list and supply that list as an iterable to any, and then any will give us the answer, which in this case should be true. So that's quite good. It's quite a useful function if you've got that sort of test that you need to do, and there's a very succinct way of using it for a reasonably complicated question that you're asking it. So move on to some of the other functions that we've got. So there's a lot of functions that are related to data types. So I've just listed them here so I don't have to scroll back. So all of these are different data types. You know, you've got bool as your true and false, string is your text, int is your integer, float is your floating point numbers, and we've got dictionaries and complex numbers, etc. Okay, so each of those has a function, and the function can be used to create a value of that type. So here's an example. We want to use the list function, and you see how hovering in Google Colab will actually give me the help function itself, so I don't actually need to call help on it. I can just see what is there. It's a mutable sequence of values. So let's run it, and we get an empty list because we didn't provide any data in there. Now some of these functions, for when you're talking with data types, they actually convert from one data type to another. So I've got a data value here of 12, which is an integer, and I'm passing it to all these functions. So I'm passing it to int, I pass it to float, complex, and string. And we'll see what that integer comes out as using each of those functions. So the first one, it just returns 12, which is an integer. The second one, it returns 12.0, and that's a float. The third one, complex. So a complex number is it's like a real number, but it's got a real part and an imaginary part. The imaginary part being the square root of -1, because you just have to imagine that can't exist. But in mathematics, it's actually got some uses to have complex numbers where they deal with the square root of -1, which is referred to in this case as j. So if you have an integer of the value 12, that's equivalent to the complex number, which is 12 plus 0j. And our string value of 12 is the digit that's 1 and 2 as characters in a string. So that's how you can convert from one data type to another just using these built-in functions. Similarly, you can use tuple, list, set, and frozen set to convert all of these. I'm providing a tuple to each of these, except to tuple, which I'll provide a list, and then converting them using the built-in functions. And you can see the list got converted to a tuple with the parentheses rather than square brackets. The tuple there with the parentheses got converted to a list, which is designated with square brackets. The set got converted, the tuple got converted to a set, which is designated by curly braces. And also a set has to be unique. So the second value of 2 wasn't able to be in the set. So when it got converted, any non-unique values were cleaned out. So that's a way of getting a unique set of a bunch of values. It is a mutable value, which means you can change it. You can add more values into that set if you want, or take some out. If you want it to be immutable, which means you can't change it, then you call it a frozen set. And there is no key on the keyboard that represents frozen set, so we just display it with the word, Python just displays it with the word frozen set, so I know what it is. So there's some examples of collection functions, or dealing with collections of things using numbers. We can also do it with letters, and when we feed in data to one of these functions and it sees a string, it goes, string, I can iterate over that. I can go through each of the letters in the string. So the list of the string kayak gives me K-A-Y-A-K, and it splits it all up into the individual letters. When I do a set on that, it even goes, well, some of these letters are not unique, so the unique letters are A, K, and Y. So that can be useful. Sometimes it can be painful. That's not what you wanted. Say, for example, you wanted a list with the word kayak in it, then you can pass it that, and let's see, if we give it a comma, then it'll go, that's the collection. It didn't work, so we can pass it as a tuple. And it's not going to like that because I haven't closed this parentheses. There we go. And so now I've got it in there. But I basically had to use the other form of designating it. I could have put in 2 words like that. No, you can only provide 1 argument to these, so it has to be an iterable. Yep. It doesn't like Google Colab's trying to help me by adding extra parentheses in there. Okay. So this is the advantage of interactive Python. You can just try things quickly to see if they work and quickly fix them up, rather than have to run your whole code and then sort out where the errors are later. Okay, challenge 2. Create a list of the unique characters in beginner's Python and machine learning. Alright, so we'll grab that phrase, store it in a variable, and we want to use a set of phrase. That'll do, and that'll show me all the unique characters. And there they are, A, B, C, D, E, G, H, and so on. And so, in the solution, I thought I'll introduce another built-in function, the sorted function. But as you can see, they are actually already sorted, so creating a set has decided to sort it for us automatically. So let's get some help on sorted, see what sorted does for us. So it's got an extra parameter we could pass in to have it reverse sorted. So let's try that. And there we go. It's sorted returns a list rather than a set, and it's in reverse alphabetical order because we've specified reverse here. So a list can actually have duplicates, but because we've done a set first and then done the sorted, there are no duplicates in that list. So talking about the different data types, these are the mutable ones: byte array, dict, list, and set, and these are the immutable ones. So all of these ones, you can't change the value in place. You can assign the variable to a new value, but you can't change an existing value, and that's what immutable means. So dict, let's have a look on dict, which is dictionary. So I've told you how to use help before. Now a lot of these will have a attribute called _doc, and people read that by calling it dunder doc. So dunder means starts with and finishes with double underscores. So if I print dict dot $_doc $_, then it prints out the doc string for that function. So there's different ways of creating an empty dictionary. You can create an empty dictionary with nothing in the parentheses. You can provide a mapping, which can be a list of key value pairs. You can do something that's iterable, which would do something for k, v. In iterable, the dictionary with the key of k will have a value of v. Or you can use expanded keyword arguments, which is the way you normally can call a function. You can give each parameter or argument in the parameter list, it'll have a name and a value. So we've got here dict1 equals 1, 2 equals 2. So here's an example of using the keyword arguments. We're going to create a dictionary with 3 elements. The key A is going to have a value of alpha, the key B is going to have a value of bravo, and the key C is going to have a value of Charlie. So that's one way of creating it. We could have actually just typed that in, but that wouldn't be using our built-in functions, which is what the purpose of what we're doing here. Alright, so they're keyword arguments. This is an example of using an iterable. So we've got a list, that's our iterable, and in the iterable we've got these pairs of data. Each pair starts with a key, and the second item in each pair is a value. So if we run that, we get key P, value Papa, key Y, value Yankee. So we're up to challenge 3. Create a dictionary of the following Roman numerals. So 1 equals I, 5 equals V, 10 equals X, etc. Alright, so I'm going to get in there, and I'm going to try to create it using keyword arguments, because that's how it's written out. And let's see how successful I'll be doing that. So I'll say D equals a dictionary, and it's looking at the answer. We don't want that. Now I want the keys to be integers and these values to be strings. So I have to put quotes around the strings. Now Google Colab's giving away the problem we're going to face here. It's underlined all of these parameter names that we've put in there and said there's something wrong with them. So let's run it and see exactly what is wrong with them. Expression cannot contain assignment. Perhaps you meant equals equals, which would be working out if it's a Boolean expression. But what it's really saying is in a function you can't have a parameter name that's an integer or a number. It has to be a string or some valid variable name. So if I wanted to do that, I would have to do it this way. So well, we've seen that doesn't work. So let's do a list of tuples. There's the first one. And that's why you need this way of actually creating it, because there could be some reason why the keyword arguments didn't work, which we just found. One of the reasons is we weren't using valid parameter names. Now this is quite a lot of typing, and so when we finish this we'll look at the solution, which has got a much quicker way of doing it. So we'll close our list with a square bracket and now run that, and that worked. We should have a look at what's in D after we've run it, and there's our dictionary. And so it's quite legitimate for a dictionary to have keys that are integers, but a function can't have parameter names that are integers. So we use this different form of the function to create our dictionary. Alright, Leo's off, so thanks Leo for watching. So solution 3, introducing a different built-in function called zip. So the zip will take 2 lists and it will apply, well in fact it can be more than 2, and it does like what the teeth of a zip do, is they alternate from one side to the other and produce a list of tuples. So in this case I'm taking all my keys and then I'm going to interleave them with my list of letters from my Roman numerals, which I can just put in as a string, because remember string is iterable, and create my dictionary of Roman numerals. And that worked. And if you want to see what zip is actually doing, let's just create a new code cell. And just extract the zip part and run that. Well, that's created an iterable, and then we want to actually see what it creates. So we'll put the results of this into a zip, into a list. And that's what it's created, everything that's inside the list. But then if you then send that through to a dict function, it will create the key value pairs that we can see here. Alright, now a lot of the built-in functions are to do with iterables and iterators, and by having them there we can actually really reduce the amount of code required when we're working with these iterables and iterators. And it's one of the big advantages of Python over other languages like Java, which are quite verbose when doing that. And Java's trying to they're making changes to Java to try to improve this, but Python really excels in how succinct it can do these manipulation of iterators. So some of these functions, max, min, sum, they can perform mathematical operations over the iterable. So the max will find the largest value, min will find the smallest, and sum will add them all up. And we're going to do that on all the keys in our dictionary. And the maximum value of them was 1,000, as you can remember. Here's our maximum value up here. The minimum should be 1. But notice how this time we didn't actually put dot keys in there, and that's because when you're using a dictionary and you use it as an iterable, it will assume that you're looking at the keys, because that's what most people would want to do. And so then that looks even neater. We can then sum out all our keys, and it comes to 1,666. So if you add up all these numbers, that's what you'll get. And similarly, if you do a for loop around dict Roman, it'll assume keys once again as the iterable for the for loop. And so you print out I, and you can see it's just printing out the keys. Now here's a built-in function called iter that can make an iterator out of any iterable thing. So dict Roman has got some keys, so that makes it iterable, and we're going to store our iter into our variable called iter Roman, and we're going to print the next value, keep printing the next value of it. So this is actually how a for loop works. A for loop will convert it to creating an iterator and then running the next function, another built-in function, on the iterator, and each time it gets a new value. Now I've just done it exactly the right number of times. How does the for loop know when it's got to the last one? And I'll show you what happens if we tried doing it again on the last one. So it'll do them all, and then after the last one it'll have this stop iteration exception, and that exception tells the for loop stop here, and it catches it so we don't get all this ugly display coming out, but that's just how it knows. And so that's the structure of an iterator, and your iter function will give you one of those. And you can see here you pass in an iterable to the function iter, and you'll get an iterator out. You can also pass in a callable, which is so a callable is a function. Anything that you can put parentheses after it and call it is callable, and a sentinel being some sort of thing that it will return when it gets to the end. Like in our case, we threw a stop iteration exception, but that's how the iter function will work. Challenge 4. Convert the dictionary of Roman values into a list of key value tuple pairs, like that, without using items. Okay, so let's have a look at what items would do. So items is not a built-in function. Items is a method on the dictionary object. So anytime you've got a dictionary, you can call it, and that that produces that, but it's of type dict items. So if we want that to be a list, we can convert it to a list. There we go, a list of tuples. So that's what we're trying to get, but we want to do that without using items, because that's just too easy. Alright, so what we'll do a for loop. First of all, we create our empty list, and then we'll link over the dictionary, and we'll append a tuple containing the key and the value, which is that's how you get a value out of a dictionary, and then we'll look at the final list. Okay, and the AI has worked out exactly what we're trying to do, so let's go with that, because that's all actually correct. I'll delete this bit at the beginning, and it gives us the same answer. So solution 4, and this is using the zip function, and we're using we get an iterable of all the keys, an iterable of all the values, and we zip them, interleave them together to create a zip, and then we get a list out of that. So there's another way of doing it. Okay. So let's look at more in our for loops, and we're going to look at a few more built-in functions. So see if you can find which built-in functions we're going to use here. Obviously print is a built-in function. We've been using that quite a lot tonight. Then we've got range is a way of doing a for loop. So if you go for I in range 6, it'll go through the loop 6 times, starting at 0. So the first time I will be 0, then 1, then 2, then 3, then 4, then 5. So it'll go all the way up to, but not include the number 6, but that'll be 6 times it'll iterate through. So range is a good way. If we want to see how long we want to go, how many times we want to go through it, we can look at the length, once again, another built-in function of our list of privates, being all those values that started with underscores. And then we can do the same using enumerate, which means we don't have to calculate the length and create a range object. All we have to do is enumerate all the values in our list, and enumerate will produce those values, but also produce a counter as we go through them. And so I can put 2 variable names here in my for loop, and the I will get the counter and the V will get the value. So let's run it and see. So for loop using values without a counter, and we get that. So that's good. Now we use length to get the length, which is going to be 10. Then we're going to create a range, so it's going to go from 0 to 9 for value I, and then for each value of I, it's going to look up the dictionary and say, look up the list by index and say, what's the 0th item in the list, what's the 1th item, what's the 2nd item, the 3rd, the 4th, the 5th, and so on. And then we do the same thing, but this time we're going to use enumerate, which is one of our built-in functions, very useful because it's a lot easier code to understand, and it just gives us a counter as well as the values as it goes through. So we don't have to do function on function of our list. We don't have to do value lookup by index. It just automatically puts it into our I and V. Okay, print out all the built-in functions from list functions, 6 per row. Okay, so how did we do it before? We'll find an interesting way of doing that, because we had a number of columns. Right, we had nested loops. So let's do nested loops again. Here we are. For I in range, and we'll go we'll start from 0, we'll go up to length of list functions, and we'll go and we'll step up by 6. And our AI has jumped in and come up with a pretty neat little way of doing it. Each time it's going to print 6 values out of our list of functions. So let's try that. There we go. 6 functions per row. That's a little bit, it's not very neat. So let's change that. Now we'll do a nested loop. We'll say for j in range 6, if I plus j is less than list functions, that's a good test to do. Print the list functions and a space at the end, and then after we've finished our j's, print a new line. And the other thing we might want to do is format this, so we're going to use an f string for formatting it so that we get our columns aligned. And by using an f string, I can say I want this to print out, but I want it to be 15 characters wide. There we go. So there's our 6 columns with all the functions, alphabetical order, going across as we count. So that's a reasonably complicated thing to do. Let's have a look at the solution. For I, v in enumerate, well, that was a good thing we could have done. We could have enumerated. Well, we couldn't have enumerated the way we've done it with nested loops. We had to calculate I and j, and then do an index lookup of I plus j. But by using enumerate, we can just print a new line when I gets to 6, and so we can just keep printing across the page, and then new line after 6 items will be printed. And we get the same list. Yep, all good. Filter. So this is a built-in function, and let's hover over it. So it takes a function or none and an iterable. And the function is something that will return the value if it's true. So our function, we're going to create a function here that says, does it start with a vowel of a string? So we'll pass in a string. We'll look at the first character of the string and see if it's in A, E, I, O, U, which is one of all the 5 vowels. And if it is in there, it'll return true. If it's not, it'll return false. And then we'll put the results of all those into a list, and let's see what we get out. So these are our list of functions that we're familiar with, and you can see that all of them start with vowels. So all the ones that don't start with a vowel have not been included in the list. So that's pretty useful. Often you'll have much more complicated functions than just starts with vowel, but it's a good way of applying a function to a whole list of things and filtering out just the ones that you want. Map is similar to filter, but what map does is it actually applies a function. It calls a function using our iterable as the feed to the map. Let's have a hover over it just to see. Yep, so map, first argument is a function, and the second argument is the iterables that are going to be applied, that function is going to be applied to. So this is really quite good that we can, in Python, we can just pass in a function name and it's just treated as an object. In other languages, it's a bit more difficult to do that. So hex is one of our built-in functions, so we can just apply the name. And so hex converts a value into a string, being the hexadecimal value of that integer. So you really should be providing an integer. So let's run that. And remember, because Dick Roman's dictionary, when it's expecting an iterable, it just looks at the keys. So the keys were the integers 1, 5, 10, 50, and then 100, 500, 1000. Okay, and so it's converted each of those numbers into hex, and the way it's designated a hex for us is it puts 0x out the front, and we go, oh yeah, that's an integer with a value in base 16. So 0x1 is the value 1, 0x5 is the value 5, just like normal integers. 0xa, because we've run out of digits, in base 10 there's only 10 digits, and base 16 we need 16. We use the letters A to F to supply the extra ones. So A by itself, that's equivalent to our decimal value of 10. And so if we want to convert 10 to hexadecimal, we get 0xa. This value here, 0x32, you can convert that back to decimal. It's 3 times 16 plus 2 times 1. So 3 times 16 is 48 plus 2 equals 50. And that is what we started with. 64 is 100. Sorry, 64 is 100. 1F4 is going to be 500. And I could work that out, but so it's 1 times 256 plus 15 times 16 plus 4, and that gives you 500. And similarly, 3E8 is going to be 3 times 256 plus 14 times 16 plus 8. So possibly not so useful just converting things to hex. I mean, maybe it is, but there are other times when you will want to apply a function to a whole list of values, and so map is a good way of doing that. Here's an example of using map with zip to create a new dictionary. So this one is using, now we've got keys in hexadecimal and then values in Roman. So I'm not sure when you're going to be want to use that, but maybe it's going to be useful. So 0x32 convert to Roman is L. So now you've got a conversion table for converting them. All right, let's look at some of the maths functions that are in our built-in list. ABS is the absolute value, so if it's positive it stays the same, if it's negative it gets converted to positive. Div mod, that's equivalent to floor division and then modulus, so it's basically the same as dividing and getting the remainder, finding the quotient and remainder when dividing two numbers. Pow is a way of calculating the base to exponent, which we've got another way of doing that in Python. You could just use asterisk asterisk operator, which also does the power. You can also do base, exponent, and modulo using the power function, and that's equivalent to this command, but is actually a lot faster. So if you ever needed to calculate that expression, use the power built-in function rather than the Python expression. Round is for rounding a number to a number of digits after the decimal point, and it does round half even, which means if it would produce an even number, it rounds up to produce an even, or rounds down to produce. So as if the last number is 5, it'll round up to produce an even number, or down to produce an even number, depending on what the number before the 5 is. Okay, challenge 6. Find a quotient and remainder from integer division of dividend 25 divisor 7. Okay, so I can use the Python expressions to do that. 25, 7, that'll get me the quotient, and I can do a comma, so I can get 2 results on the same line. Google AI has worked out what I'm doing and has suggested using the modulo expression for that, which is correct, and so I get 3, 4. So 25 divided by 7 is 3, remainder 4. Now we could have used the div mod function, so what answer does that give us? 3, 4. So it's the same thing. Classes and object-oriented programming. So here's the list of all the built-in functions that are to do with classes and object-oriented programming. So that's beyond the scope of today's session. But type is a useful one. We can find the type of a value. So we call a function, it's a built-in function of, in this case, the number 3, and we'll compare it to int and see if that's true or false. And that's true. Compare it to bool, and that's false. We can compare the value false to bool, and that's true. And so what would that look like? What is it actually returning? So yeah, the type of false is returning a bool, bool, and so if we compare it to bool, it gives us true. Type of false is an int, that's false because it's a bool, so bool doesn't equal int. However, there's another built-in function called isInstance, and that's useful when you're doing classes. You can have inheritance, which means that if something's a subclass, then it's still an instance of that of the superclass. So true is an instance of bool, and now bool is actually a subclass of int. So when you say is true an int, and the answer is yes, it is. Is 3 a bool? And then no, it's not, because that's a it doesn't work the other way around. So int is a superclass of bool, not a subclass. And functions are objects before as well, which is what we talked about before. And there's a special built-in function called callable, where you can check if any object is actually callable and can be used as a function. So let's try callable on print, and that comes up true. So we can call print. We can put parentheses after the word print and do something with it. We can call it. What about dunder doc? And that's false. So we can't call doc by putting parentheses at the end. Okay, well, I hope you found that useful. It is fascinating to look at the list of functions that the Python developers thought were the ones that you needed to use so much that they're going to make them built-in functions and really save you on code. You know, they're there. It makes your code very clean when you're using them, because you don't have to import libraries to be able to use them. You don't have to use them in a particular namespace. They're just there. So are there any questions about this? Next week is going to be an absolute beginners session. So we did a few things today that were a bit more advanced. But next week we'll go back to absolute beginners, so you can ask in fact, any time you can ask the questions from the very basic to very advanced, and we'll just give it a go of answering them. But next week we'll be looking at I can't remember the topic for next week, but it will. Let's have a look at what's happening next week. Lists and dictionaries. So we've done a little bit with lists and dictionaries today, but next week we'll be doing it for absolute beginners, so going through some of the stuff in a lot more detail. And we'll be doing tuples as well. Any questions? I hope you enjoyed it. I think in a few weeks' time we'll start getting some more machine learning sessions coming along, which I think there's people are looking forward to. And we'll just do our best there. And if anyone wants to volunteer for presenting a machine learning topic, either online or in person, then get in contact with me over Slack, and we'll see what we can organise. Thank you very much. Thanks, Curiosity. Glad it's always good to be curious about things.